Hello, this is the first in a series on dividing polynomials, and in this section we will discuss long division of polynomials. There will be another video for synthetic division and another one for the remainder value theorem and the factor theorem. So you can view the video that's appropriate for what you're struggling with or what you need additional help on. So this is just focusing on long division. So I put a problem here for long division just with like numbers, because what we're going to do with polynomials is very analogous to what we would do with doing long division with just numbers. So when we look at this number, we have 13,526 divided by 11. And when we do this, we're always going to look, we're going to take our 11, we're going to look at just the first digits, this 13, that we can divide by 11. So we're not going to look at the whole number right away. Just like with the polynomials, we won't look at the whole polynomial right away. We'll just look at the leading term. So here we just look at this 13, and we can say 11 goes into 13 once. And then we multiply, right? We do 1 times 11, and this is equal to 11. And now we subtract. So 13 minus 11 is 2. And then we bring down our 5. And we say, how many times can we, how many times can we put 11 into 25? So this is going to be 2. And then we do 2 times 11. 2 times 11 is 22. And again, we're going to subtract. We subtract this, we have 3. And then we bring down, 11 can't go into 3, so we bring down the 2. We say, how many times does 11 go into 32? Well, 3 would be 33, but that's too big, so we have to do 2 again. This is 22. Again, this is 2 times 11 equals 22. We're going to subtract this, and we get 10. 11 doesn't go into 10. So we've done that step correct, and we need to bring down this 6. So now, what can we multiply times 11 by to get 106? This is going to be 9. And then again, this is 9 times 11 equals 99. I'm going to subtract this, and we get, what do we get? We get 7. So 7 is our remainder, and we can just write it as a remainder of 7, or we can write 7 over 11, which is our divisor. So I don't like the way that 11 looks, sorry. That 7 over 11. Okay, so these are the basic steps. This should be completely review, but it helps us when we think about the long division. And just some terminology. This 11 is our divisor. So what we're dividing by is our divisor. What we're dividing is our dividend. Our answer is our quotient. And we have our remainder divided by our divisor is the way we write that. And yeah, okay. So let's take a look at an example with a polynomial. So we have x squared plus 14x plus 45 divided by x plus 9. So when we look at this, again, we're just going to look at the first term. So we're looking at this x and this x squared. Just like here we looked at the 11 and the 13, we're just looking at that first term. And we want to say, what do we have to multiply x by to get to x squared? Well, that's just x. And I'm going to put that x term over the x term in my dividend to keep things straight. So now we're going to do x times x plus 9, just like we did 2 times 11 over here, right? So x times x plus 9, well, that's x squared plus not x times 9 is 9x. And just like we did in long division with numbers, we're going to subtract this whole term. So x squared minus x squared, that term goes away. 14x minus 9x is 5x plus 45. So we bring down the 45 now. And now we say, what do we have to multiply x by? We're going to just look at this leading term, this 5x. Well, that's 5. So we're going to put a plus 5 up here. And now we do 5 times x plus 9. Okay, well, 5 times x is 5x. 5 times 9 is 45. So we subtract, then we're going to subtract this whole thing, just like we do with our numbers, right? 5x minus 5x is 0. Those terms go away. 45 minus 45 is 0. So we have 0 remainders. So we can write this a couple of ways. We can write this as x squared plus 14x plus 45 divided by x plus 9 is equal to x plus 5. Or we can write this as x squared plus 14x plus 45 is equal to x plus 9 times x plus 5. And we can FOIL this out and check it to verify that. But when we have no remainder, it's clear cut and straight like that. Okay? So let's take a look at another example. We have this. We have 2x cubed minus 3x squared minus 11x plus 7, and we're dividing it by x plus 3. So when we do this, we're looking at our leading terms. We're looking at x, and we're looking at 2x cubed. So we have to say, what do we multiply x by to get to 2x cubed? Or what, if we factor in x out of 2x cubed, what do we have left? So that's 2x squared. We're going to put that up here. Now again, we're going to multiply 2x squared times x plus 3, right? So 2x squared times x, that's our 2x cubed, and we designed it to get rid of that term, so that looks good. And then 2x squared times 3 this is plus 6x 6x squared, okay? Again, we're going to subtract this whole thing. So 2x cubed minus 2x cubed, that goes away. 3x squared minus 6x squared, that's negative 9x squared. Okay? Again, we're going to bring down this next term, minus 11x. Okay? And now we have to say, what do we have to now again, we're going to look at our leading term, this negative 9x squared, and our x. So we have to multiply this by negative 9x, right? So again, this line is going to be negative 9x times x plus 3. And that's going to be negative 9x squared minus 27x. Okay, and again, we're subtracting this whole thing. When I have subtraction, I have negative signs. I just go ahead and make this positive and change all the signs, right? Because a negative times a negative is going to be positive. So 9x squared, negative 9x squared plus 9x squared, these terms cancel. Negative 11x plus 27x is 16x. Now we're going to bring down this 7. Plus 7. Okay. To multiply x, again, we're looking at our leading term, this 16x, so we have to add plus 16 here. 16, and then this again is 16 times x plus 3. So this becomes 16x, and 3 times 16 is 48 plus 48. And again, we're going to subtract all of this. 16x minus 16x is 0. 7 minus 48 is negative 41. So up here, we have negative 41 as our remainder. And if we want to write this here, we're going to write plus 41. Or actually, sorry, that should be minus, right? Because we had a negative 41. 41 divided by x plus 3. Okay, Now again, we can write this a couple of ways. This is our quotient. We can write this as 2x cubed minus 3x squared minus 11x plus 7 divided by x plus 3 is equal to, our quotient is 2x squared minus 9x plus 16 plus, minus 41, which is our remainder, over x plus 3. The other way we can write this is we can write this as 2x cubed minus 3x squared minus 11x plus 7 is equal to, our divisor is x plus 3 times our quotient without the remainder, this 2x squared minus 9x plus 16, and then plus our remainder, which actually is negative 41. Okay, so essentially we're multiplying both sides by x plus 3, and we just pulled this last term out. But this is our divisor and our quotient. So we divisor minus our quotient plus our remainder. Okay, so if this was f of x. Okay, so this will become important as we move along through, when we take a look at the remainder value theorem and our factor theorem. Okay, so this is just the basics of long division. There will be another video on synthetic division, which is very useful, and another one on some of the remainder value theorem and the factor theorem. So if you have questions on that stuff, please take a look at those videos as well.